Welcome to the deep dive. Today, we're pulling back the curtain on a secret giant, an ingredient that, well, it pretty much dominates your entire grocery store.
It really does.
We're talking about something that is silently in about half of all the packaged products you buy, yet it remains one of the most polarizing and debated substances on the planet.
We are talking about palm oil.
And it is truly astonishing how this one single vegetable oil has become so utterly ubiquitous.
It is. For this deep dive, we've gone through a massive file that charts the entire lifespan of palm oil. We're tracing its ancient history, its chemical perfection for industry, and really analyzing the major health, ethical, and environmental conflicts it presents.
Right, and our sources are dense. We're drawing on health authorities like the European Food Safety Authority, that's EFSA, and the WHO, alongside detailed environmental reports from groups like the WWF and Greenpeace.
And foundational texts, too, like Jocelyn Zuckerman's Planet Palm, which really gets into its destructive history.
So our mission is crucial here. We want to understand not just the headlines about, deforestation, but to get to the core of why. Why did it become so indispensable?
Exactly. And what is the true cost of that stunning efficiency?
Okay, let's unpack this. Let's start with the basics. What exactly is palm oil, and why does the industry love it so much?
So, chemically speaking, it's an oil extracted from the fleshy orange part of the fruit, the mesocarp of the African oil palm.
And it's important to distinguish it from palm kernel oil, right?
Absolutely crucial. That comes from the seed, has a totally different fat profile.
Mm-hmm.
The raw oil itself, before any processing, is this deep red-orange color because it's packed with beta-carotene.
And what's the one physical property that made this oil the ultimate industrial superstar?
That's what it does at room temperature. Most
Yeah.
vegetable oils, olive, canola, they're liquid.
Right.
But palm oil is naturally semi-solid, and that quality means manufacturers don't have to hydrogenate it.
Which is the process that creates the bad trans fats.
Exactly. It's chemically ready-made to provide the perfect structure for everything from margarine to biscuits to, well, almost anything.
That semi-solid nature is the commercial magic. And yet, this isn't some newfangled chemical fix. This is where it gets really, really interesting.
Not at all. I mean, we are talking about an ingredient with a 5,000-year history.
5,000 years.
Yeah. Archaeological evidence from the Abydos excavations in Egypt shows it was used as early as 3000 BCE. For millennia, it was a traditional regional staple food.
That seriously undermines the idea that this is just a quick, modern industrial fix. What kept it in West Africa for so long before it just exploded globally?
It really boils down to infrastructure and need. For centuries, West African communities used it locally.
Yeah.
For cooking, medicine, skincare, the global demand just wasn't there.
Until
One specific event, the 19th century British Industrial Revolution.
Suddenly, the world needed vast, cheap industrial inputs.
Precisely. Imagine those 19th century London factories, just churning away. Their machinery needed a cheap, consistent lubricant. And on the consumer side, companies like Lever Brothers needed an affordable, stable fat to mass-produce soap.
And palm oil was the answer.
It arrived via British ships, and it perfectly filled that demand. It was cheap, reliable, and just essential for that new industrial economy.
And then it had a second explosion, right, just a few decades ago in the food sector.
Yes. In the late 20th century, the health risks of artificial trans fats became major news. Remember that public health push?
Oh, absolutely.
Well, manufacturers panicked. They needed a natural fat that could stay solid and extend shelf life without hydrogenation. Palm oil was basically waiting in the wings, the perfect replacement.
That dual history, ancient food, industrial lubricant, modern trans fat replacement, that explains why it is now inescapable.
Its versatility is just unparalleled, which is why we talk about the 50% rule. Palm oil, or one of its derivatives, is in roughly half of all packaged goods today.
Let's just run through a quick list because the breadth is staggering.
Okay, so in food, it's all about structure and texture. It gives you the spreadable quality in margarine or, Nutella.
Of course.
It provides the crisp structure in biscuits and chips. It makes ice cream smooth and creamy. And crucially, it radically extends the shelf life of instant noodles, soups, thousands of things.
And even if you manage to avoid it in your food, you're still probably covered in it by the end of the day.
Oh, absolutely. In the non-food sector, it's an emulsifier, a foaming agent in detergents, shampoos. It's in cosmetics, especially lipsticks and foundations, to stop them from melting.
Wow.
And beyond that, it's processed for biofuel, a diesel alternative. Its reach is truly global.
Okay, so it's clear manufacturers need it stable and odorless, but is that processing what fundamentally changes this ancient food, moving it from a benefit to a potential risk?
That distinction between the raw and the refined is absolutely crucial to the health equation. If you consume it in its original, unrefined state, often called red palm oil, used in traditional African cuisine, it is in fact incredibly beneficial.
I've seen some of the reports on that. They're genuinely compelling.
They are. Unrefined palm oil is an antioxidant powerhouse. It has 15 times more vitamin A precursor, that's beta-carotene, than carrots.
15 times.
15. It's also one of the best natural sources of a form of vitamin E called tocotrienol, which some studies suggest is great for brain health. It is, nutritionally, a superfood in its raw state.
But is that dosage still relevant in a modern diet, even if a company did use red palm oil?
Oh yes, absolutely. But here's a massive problem. That nutritional value is tied to its deep red color and its very distinct flavor.
Which manufacturers want to get rid of.
Exactly. They have to remove those qualities to hide it in a cookie or a shampoo. So this healthy red version is almost never the one used in packaged goods.
So the refining process, that industrial removal of color and odor, that's where the risks emerge.
That's right. Industrial refining means heating the oil above 200 degrees C, sometimes higher. It's for stability, for shelf life. But that sustained high heat processing is where the trouble begins, chemically speaking.
And this heat creates some very worrying byproducts.
It does. We have to talk about the major finding from EFSA back in 2016. They found that high-temperature refining creates contaminants called 3-MCPD and GE, which are glacidyl fatty acid esters.
Can you walk us through how those are formed? It's pretty technical.
It's a chemical reaction. It's driven by the temperature. These compounds form when the oil is heated that high, especially in the presence of chlorides, which are just naturally in the crude oil.
So it's not an additive.
No, it's a byproduct. The heat forces the fat's own molecules to react and form these new compounds, and EFSA identified them as potential carcinogens. They issued a significant warning, especially for infants and young children.
So it's not the fat itself, but an unintended consequence of industrial necessity, turning a red, flavorful oil into a white, odorless commodity.
Precisely. But beyond that, we also have to look at the oil's inherent chemistry. Compared to, say, canola oil, palm oil is very high in saturated fat.
In what specific type are we talking about?
It's roughly 50% saturated fat, mostly palmitic acid. The World Health Organization has been really clear on this. High saturated fat intake can increase LDL, that's the bad cholesterol, and raise the risk of cardiovascular disease.
So you've got a double-edged sword, a high saturated fat content, plus the risks from the carcinogenic processing byproducts.
Exactly.
Okay, so widening the lens. The health conversation is deeply concerning, but the most visible and frankly the most emotionally charged controversy is the ecological destruction.
That is the central, undeniable ethical dilemma. You have to look at the geography. 85% of global palm oil production comes from just two countries, Malaysia and Indonesia.
And that concentration is tied directly to the clearance of their primary natural resource?
Tropical rainforests, yes. The drive for these massive, high-yield monocultural plantations requires clearing gigantic tracts of land. And this is cited as the leading cause of a catastrophic biodiversity crisis.
The scale is just devastating.
It is. We are talking about clearing areas the size of small countries year after year. And these rainforests are the habitats of critically endangered species. The Sumatran tiger, the rhino, the elephant, and of course the orangutan.
The orangutan has become the global symbol of this crisis. Why is their population so uniquely vulnerable?
It's because they're arboreal. They live their lives in the trees, they move in the canopy, and they reproduce very, very slowly. When their habitat is just bulldozed, they lose everything. Reports clearly cite the palm oil industry as the #1 driver of their critical decline.
Their homes are literally being turned into farms.
Yes, and if that wasn't enough, this process is also a massive contributor to the climate crisis. The method of clearing land is often slash and burn.
Especially on peatlands, right?
This is where the climate link becomes so incredibly clear. Peatlands are these ancient natural carbon sinks. They've stored enormous amounts of carbon over thousands of years.
So when you burn them,
You release all that stored carbon at once, straight into the atmosphere as CO2. I mean, journals like Nature, Climate Change don't pull any punches. They've shown exactly how disastrous this is for global carbon emissions.
Okay, so in response to all this pressure, the industry has tried to come up with a solution. This idea of sustainable palm oil.
Yes, the leading response was the creation of the RSPO, the Roundtable on Sustainable Palm Oil. It's an organization that certifies palm oil that is supposedly produced without further deforestation.
Supposedly is a key word there. The sustainability challenge gets murky right there, doesn't it?
It really does. Environmental groups like Greenpeace are highly critical of the RSPO. They argue the audits are often insufficient and that the certification doesn't always translate to real change on the ground.
When they say insufficient, what are they pointing to? Is it a problem with the supply chain, or are certified plantations still causing harm?
It's both. First, there's a lack of chain of custody monitoring. It's hard to be sure certified oil isn't mixed with uncertified oil. But more critically, they argue the standards are too lax and enforcement is too weak.
So they find evidence of bad practices even with the certified producers.
Yes, they claim they still find evidence of deforestation or use of protected areas by some certified producers. It makes the RSPO tag look like greenwashing, at least in some cases.
So if we connect all this back, we land right in the middle of a paradox. You have this ingredient that's chemically perfect for half the supermarket, causing terrible damage, but it is also astonishingly efficient.
That efficiency is the single most important data point to understand this whole conflict. Insiders call it green gold because of its spectacular yield. To satisfy the world's demand for vegetable oil, palm oil requires the least amount of land, period.
What does that look like in terms of numbers?
Compared to its main alternatives, soy, rapeseed, sunflower, the oil palm yields 5 to 10 times more oil per hectare.
5 to 10 times. Wow.
Which means if we banned all palm oil today and replaced it with soy, we would need to clear 5 to 10 times more land globally to meet the same demand.
That one fact explains its market dominance better than anything, and it puts the consumer in a genuinely tough spot. Since completely avoiding it is nearly impossible for most people, what can our listener actually do with this knowledge?
That's the key question. And the vigilance starts with extreme label reading.
Which is much harder than just looking for the words palm oil.
Oh, much harder. You have to look for aliases. Palm oil, of course, palmitic acid, but also be aware of the dozens of derivatives in cosmetics and cleaners. Sometimes they'll use the word palm in parentheses, but often they don't use it at all.
So chemical names like sodium lauryl sulfate.
Exactly. Or sinyl alcohol, stearic acid. These are often, though not always, derived from palm oil. The lack of standardized labeling makes it so difficult.
So reading labels is basically detective work. What's the next step?
Control what you consume at home. If you make your own food, you can choose fats like olive oil or butter. That eliminates the hidden palm oil entirely. And thirdly, if you have to buy packaged goods, look for the certification.
The RSPO logo.
Yes, look for RSPO certified products. Even with the controversy, it represents at least some commitment to accountability from that producer.
Palm oil really is a complex symbol of our modern world. It bridges 5,000 years of history. It represents the efficiency we demand, but it carries this heavy, heavy environmental and ethical cost.
And that leads us to the final provocative thought for you to mull over. Given that spectacular efficiency, the fact that it produces 5 to 10 times more oil per acre than its competitors, avoiding it entirely risks creating a different, maybe even larger ecological problem somewhere else.
By pushing the demand onto those less efficient crops.
Exactly. So this raises a monumental question. Is the solution to ban palm oil, scattering that demand pressure across the globe? Or is the solution to demand better, truly enforceable, sustainable production methods from the supply chain that already exists?